Welcome to the Deep Dive. Today we're tackling artificial intelligence head-on with a fantastic resource called the AI Revolution Past, Present, and Future.
Sounds great.
We're not just skimming the surface, we're pulling out the core insights, the stuff that really matters so you can understand where AI came from, what it can do right now, and, well, what the future might just hold all without needing a PhD in computer science.
Exactly. This outline, it's a real journey through the evolution of AI, and our mission is to be your guides, highlighting the pivotal moments and, explaining why they're significant. We want to give you a clear and hopefully engaging perspective on this incredibly transformative field.
Okay, so let's jump right in. Chapter 1 takes us back to the origins of AI, starting with the period between like the 1950s and the 1970s. This is where the seeds of AI were really sown, wasn't it?
It absolutely was. 1956 is key. That's when the Dartmouth Conference happened, and John McCarthy officially coined the term artificial intelligence.
Right, Dartmouth.
Yeah. It was a moment filled with incredible optimism, the formal recognition of a brand new field of inquiry. It's fascinating to look back and see the initial hopes and, well, dreams for what machines could potentially achieve.
And you really can't talk about those early days without mentioning Alan Turing and his deceptively simple question, can machines think? It still feels like the bedrock of the whole field.
Absolutely. That question, it wasn't just philosophical. It was a challenge that led directly to the proposal of the Turing test.
Ah, the Turing test.
Yeah, think of it as a practical benchmark. Could a machine behave in a way that's, well, indistinguishable from a human in conversation? It's a concept that honestly continues to spark debate about what truly constitutes intelligence.
Okay, so we had these big fundamental ideas floating around. What were the first actual attempts to build intelligent machines? Like, what did those early programs look like?
Well, we saw the emergence of programs like the logic theorist, which was actually able to prove mathematical theorem.
Oh, back then.
Yeah. And then there was ELIZA, a natural language program that could simulate a conversation, kind of like a psychotherapist. Now, these seem very basic compared to today's AI, obviously, but they were groundbreaking at the time. They really demonstrated that computers could indeed perform tasks that we associated with human intellect.
It sounds like there was a real buzz around AI in those early days, but the outline mentions AI winters. That doesn't sound very optimistic. What happened? Why did things cool off?
That's a really important point. The initial excitement and the, influx of funding were largely based on the promise of rapid progress, huge promises.
Right.
However, as researchers encountered the sheer complexity of real-world problems, they faced significant roadblocks. Expectations just weren't being met. And consequently, government and private funding began to dry up, leading to these periods known as AI winters. This boom and bust cycle, it really highlights a crucial lesson: the importance of managing expectations and focusing on demonstrable incremental progress rather than purely theoretical possibilities. That's a lesson that arguably still resonates today, actually.
Okay, so from those early sparks and then those periods of, well, slower progress, we move into the 1980s and 2000s with the rise of machine learning. This feels like a really pivotal shift in the approach to AI.
It was a fundamental change, yeah. Instead of trying to explicitly program computers with rules for every single situation, the focus shifted to machine learning.
Okay.
The core idea here is that you feed computers vast amounts of data, and they learn to identify patterns and improve their performance on specific tasks without being directly told how to do it at every step. This opened up possibilities for tackling much more complex and nuanced problems.
And during this time, we started seeing AI creep into our daily lives, maybe in ways we didn't even recognize then, like spam filters, chess engines, Netflix recommendations. These were early applications of machine learning, right?
Precisely. Think about spam filters. They learn to recognize unwanted emails by analyzing the characteristics of countless spam messages.
Uh-huh.
Chess engines like Deep Blue could evaluate millions of potential moves thanks to sophisticated algorithms learning from a huge database of games. And recommendation systems on platforms like Netflix started to learn your viewing habits to suggest other shows and movies you might enjoy. These were, tangible examples of AI learning from data to provide practical solutions.
And speaking of chess, Deep Blue defeating Garry Kasparov in 1997. That was a massive event. It felt like a real line in the sand.
Oh, it was a landmark moment. It wasn't just about a computer winning a game. It demonstrated the raw power of computational analysis combined with clever algorithms to outperform even the greatest human strategic thinkers in a complex domain. It really captured the public's imagination and signaled the accelerating progress in AI capabilities.
All right, so that brings us pretty neatly to Chapter 2, AI Today, the Game Changers. This is where things feel like they've really taken off. The first segment here is deep learning and neural networks. This seems to be the engine driving a lot of the AI breakthroughs we're seeing now.
Absolutely. Deep learning is a subfield of machine learning that's inspired by the structure of the human brain. It uses artificial neural networks with multiple layers, that's where the deep comes from, to process information in a hierarchical way.
Okay.
This allows them to learn incredibly intricate patterns from vast amounts of data. This architecture has proven exceptionally effective for tasks like recognizing images, understanding natural language, and processing speech. Think of neural networks as the basic building blocks, kind of inspired by neurons in our brains.
Right.
Deep learning simply means using neural networks with many layers, allowing them to learn much more intricate patterns in data.
And we see deep learning in action all around us, don't we? Siri understanding our voice commands, Facebook automatically suggesting tags for our photos, and the way Tesla's self-driving cars interpret the world around them. It's all powered by these deep learning networks.
Exactly. When you speak to Siri, deep learning models are at work interpreting your language. Facebook uses facial recognition powered by deep learning to suggest who might be in your photos. And self-driving cars rely heavily on deep learning to process the data coming from their sensors, identify objects like pedestrians and other vehicles, and make real-time driving decisions.
Then we get to Chapter 2, Segment 2, ChatGPT and Generative AI Explosion. This feels like a really recent and incredibly impactful development. Suddenly, AI wasn't just behind the scenes, it was like in our conversations.
The release of OpenAI's ChatGPT in late 2022 was a watershed moment, no question. It brought sophisticated AI directly to the fingertips of millions, making it interactive and accessible in a way that just hadn't happened before.
Yeah.
Generative AI models like ChatGPT have the ability to create new content, text, images, code, you name it, based on the patterns they learned from the massive data sets they were trained on.
So how does that work, basically?
Essentially, it learns the probability of one word following another in vast amounts of text. So when you prompt it, it's predicting the most statistically likely and hopefully coherent sequence to follow.
It's fascinating, but the outline also mentions AI hallucinations. That sounds a bit unsettling. What exactly are those?
Right, hallucinations, they happen when these generative models produce information that is factually incorrect, nonsensical, or sometimes completely fabricated.
Fabricated.
Yeah. It happens because while these models are brilliant at generating plausible-sounding text, they don't actually possess a true understanding of the world or, a built-in fact-checker. They're essentially really good at making educated guesses about what should come next, and sometimes those guesses are just plain wrong.
Okay. Moving beyond these conversational AIs, Chapter 2, Segment 3, looks at AI in healthcare, finance, and warfare. It's clear that AI's reach is incredibly broad.
It truly is. In healthcare, for instance, AI algorithms are being developed to analyze medical images like X-rays and MRIs, helping doctors to detect diseases like cancer at earlier, potentially more treatable stages.
That's a potentially life-saving application. That's huge. What about in the financial world?
In finance, AI is being used for a variety of purposes, from detecting fraudulent transactions and automating trading strategies to analyzing vast amounts of financial data to try and predict market trends much faster and, well, more efficiently than humans could.
And then there's the application in warfare. The outline mentions autonomous drones making life or death decisions. That's a really significant and maybe scary area to consider.
It raises profound ethical questions, absolutely. The idea of autonomous weapons systems, it raises serious concerns about accountability, control, and the implications of machines making decisions about human life. It's a topic that's generating a lot of discussion and debate globally, as it should.
This leads us perfectly into Chapter 3, The Future of AI Utopia or Doom. That's a pretty dramatic title, highlighting the very different potential paths ahead. The first segment here is AGI, when AI matches human intelligence. What exactly is AGI?
Right. AGI, artificial general intelligence. It's the concept of a future AI that would possess human-level cognitive abilities across a broad spectrum of tasks.
So not just good at one thing.
Exactly. Unlike the AI we have today, which is typically very good at specific narrow things, we call that narrow AI, AGI, would have the capacity for general reasoning, learning, and problem solving, much like a human being.
And it seems like there are very different opinions among experts about when, or even if, will reach AGI and what the consequences might be.
Oh, absolutely. Polar opposite views, really. Some believe that AGI is an inevitable outcome of technological progress and that it could potentially help us solve some of the world's most pressing issues. Climate change, disease, you name it.
The utopian view.
Right. Others, however, have serious concerns about the potential risks, including the possibility of AGI not aligning with human values, which raises complex questions about control and safety. Could it render humanity obsolete? That's the fear.
The outline mentions figures like Elon Musk and Jeffrey Hinton being involved in these debates. They've both expressed some pretty strong views, haven't they?
They have, yeah. Musk has frequently spoken about the potential existential risks associated with highly advanced AI, emphasizing the need for careful development and oversight,
Hmm.
regulation. Hinton, who's basically a godfather of deep learning, has also recently voiced significant concerns about the potential for misuse and just the sheer speed of advancement. He left Google to speak more freely about it.
Wow. Okay. Chapter 3, Segment 2, then looks at AI ethics bias, privacy, and job loss. These are some of the real-world issues we're grappling with right now as AI becomes more prevalent. Let's start with the potential impact on jobs. Which sectors are likely to see the biggest changes?
Well, many jobs that involve routine and repetitive tasks are potentially susceptible to automation through AI. That's kind of the low-hanging fruit.
Like what specifically?
Think roles in manufacturing, data entry, customer service call centers, and even some areas of white-collar work like basic legal research or, say, medical transcription. The extent and the speed of this transformation are still heavily debated, but it's pretty clear that AI will reshape the labor market in significant ways.
And bias in AI algorithms is another big one. How does that happen?
Bias often creeps in through the data used to train the AI models. If the training data reflects existing societal biases, whether related to race, gender, age, whatever, the AI can learn and even amplify those biases.
So like in hiring.
Exactly. There have been real-world cases where AI hiring tools showed bias against certain groups because the historical hiring data they were trained on was biased. This can lead to discriminatory outcomes, and it raises serious questions about fairness and accountability.
And privacy concerns too.
Definitely. AI systems often require vast amounts of data, including personal data, to function effectively. This raises concerns about how that data is collected, stored, used, and protected. Data security is a massive issue.
Which brings us to regulation. How do we control this powerful technology?
That's the million-dollar question, isn't it? There's a growing global conversation about how to regulate AI development and deployment effectively. It involves balancing innovation with safety, ethics, and societal impact. It's incredibly complex.
Yeah, sounds it. The outline also touches on the idea of AI companions and brain-computer interfaces in Chapter 3, Segment 3, Sci-Fi Becomes Reality. This starts to feel like we're moving into some really futuristic territory. What are we envisioning with AI companions?
AI companions are essentially AI systems designed to interact with humans on a social and potentially even an emotional level.
Like a robot friend.
Could be. It could range from advanced virtual assistants that feel more like conversational partners, maybe living in your phone or computer, to actual physical robots designed to provide companionship, maybe for the elderly or isolated individuals. It raises really interesting questions about how we might interact with technology in the future and what role AI could play in our social lives. The societal impact could be huge.
And then there are brain-computer interfaces like Neuralink. That sounds incredibly advanced. What's the goal there?
Brain-computer interfaces, or BCIs, aim to create a direct communication link between the human brain and external devices. Neuralink, Elon Musk's company, is developing high-bandwidth brain implants with the initial goal of restoring sensory and motor functions for people with severe disabilities.
So helping people walk again or see?
That's the near-term aim, yes. They've shown progress in animal trials, like enabling monkeys to control computers with their thoughts, and they've actually begun initial human trials focused on helping individuals with paralysis. Of course, there's also longer-term speculation about enhancing human capabilities, which opens a whole other ethical can of worms.
And digital immortality. Is that really something people are thinking about?
It's a very speculative idea, but yes.
Yeah.
The concept is essentially using AI and potentially brain scanning technology to create a digital replica of a person's mind or consciousness that could theoretically persist after their physical body dies. It's deeply philosophical and highly futuristic, but it's connected to these advancements in AI and neuroscience.
Wow. Okay, that gives us a glimpse into the far-out future. Now, Chapter 4 shifts to something much more tangible, how you can leverage AI. The first part focuses on AI tools for creators, entrepreneurs, and students. It sounds like AI isn't just for big tech companies anymore.
Absolutely not. The accessibility of AI tools has exploded, especially in the last couple of years. For creators, there are AI-powered writing assistants that can help with brainstorming, drafting content, even suggesting edits, tools that can generate stunning images and music from simple text prompts.
Like Midjourney.
Exactly. Midjourney is a prime example for images. And there's AI-enhanced video editing software making complex effects easier. For entrepreneurs, AI can help with tasks like market analysis, creating customer service chatbots, automating marketing emails, all sorts of business processes. And for students, AI can be a really powerful tool for research, summarizing dense information, getting help debugging code. Lots of uses.
The outline specifically mentioned Midjourney, which you brought up, but also Runway ML and GitHub Copilot. What are those tools capable of?
Right. So Midjourney, as we said, generates images from text prompts. Runway ML offers a whole suite of AI-powered tools mainly focused on video editing and visual effects generation, things like removing objects from video, changing styles, generating video from text. It makes sophisticated techniques much more accessible.
Okay.
And GitHub Copilot is an AI-powered coding assistant. It integrates directly into your code editor, like VS Code, and suggests lines or even whole blocks of code as you type. It can significantly speed up the software development process for programmers.
That sounds incredibly useful. And for our listeners who might be thinking, hey, I want to learn more about this AI stuff, Chapter 4, Segment 2 points to free courses and career paths. It's great to know that there are accessible ways to start learning.
There really are. There's a wealth of free online courses available now. Platforms like Google's AI education resources, Coursera often has introductory courses, ADX, and even OpenAI itself offers educational material. These courses cover everything from the fundamental concepts of AI and machine learning to more specialized topics. They can provide a really solid foundation for anyone just looking to understand AI better or even explore potential career paths in the field.
And for someone looking to actually get into the AI field in, say, 2024, what kind of opportunities might be out there, especially if they don't have a traditional computer science PhD?
That's a good question. The AI landscape is evolving so rapidly that the demand for diverse skills is really growing. While traditional AI engineering and research roles are obviously still crucial, there are increasing opportunities in areas like AI ethics and policy development, project management specifically for AI initiatives, data analysis, because AI runs on data, and even roles in communication and education around AI, explaining it to people.
So not just hard coding.
Not at all. Demonstrating a strong foundational understanding of AI concepts, maybe through some of those online courses, and showing a genuine interest in continuous learning can be really valuable assets for breaking into the field, even from adjacent areas.
Well, this has been a truly fascinating deep dive, taking us from the very beginnings of AI, those early concepts, to the incredible capabilities we're seeing today, and uh, the pretty mind-bending potential of the future. It's clear that AI is a force that's already having a huge impact on all of us.
It has indeed. We've explored the historical journey, the game-changing present with deep learning and generative AI, and the complex ethical questions surrounding its future, from AGI to bias. It's definitely a field that demands our attention and, frankly, careful consideration as it continues to evolve at such speed.
Absolutely. So, as we conclude this deep dive into the world of AI, and as you, our listener, consider its rapid advancements and its growing presence in our lives, here's a final thought for you to maybe chew on. What aspects of human creativity, connection, and critical thinking do you believe will become even more important, even more valuable as we navigate this increasingly intelligent world? It's something to really ponder as AI continues its rapid evolution.